We're looking at assessing normality using a normal probability plot. Later on in the year, we're going to conduct inference to accomplish two things. We're going to do estimation, which is confidence intervals, and we're going to do regular inference, testing a claim, like t-test and z-test and things like that. And we're going to use samples to challenge other people's viewpoints for things like means for populations. We're going to say, all right, if you think the true average on this test was 85, I just had a lot of kids that fail. I'm going to take a sample of those tests, and whatever X bar is, I'm going to either support you what you're saying or reject what you're saying. Anyway, those are the two things we're going to do, and in order for us to be able to do these things, we have to ensure that our samples are roughly mound shaped, the distributions of them. And the reason that we have to do that is because if we can find out that our sample does approximate a bell curve, it does then give us some reason to believe that the entire population fits a normal distribution or a bell curve. So it's just, reasoning from the general to the specific to the general. And so we need a way to figure out if our data set actually is normal so that we can tackle, estimation and tests of significance. All right, I'm just going to put this entire thing up here. I had promised you no more histograms. You don't have to do them by hand. They are possible to do on your calculator. Maybe one day when we have a little time, I'll show you. But for right now, you would get your data set and you would create a frequency histogram for it, and then you would chop it up. You'd find the sample mean, add and subtract a standard deviation, that's a first cut, then take the same mean and add and subtract two standard deviations, 2 times the standard deviation, that'd be your second cut, and then the same thing for plus or minus 3 standard deviations. Figure out the percent of observations in each section and see if they match up to the empirical rule. If they do, then you've got basically a set of data that can be modeled normally. All right? This is a lot of work. Even if we don't have to do frequency histograms by hand anymore, this would still be a lot of work. We're not doing this. But that's what they did back in the day, so we had to start with this somewhere. This is where we start. Okay, so instead of that, we're going to construct a normal probability plot. And even that sounds tedious. We're just going to let a calculator do it, okay? But what is a normal probability plot? It's a 2-variable graph, which is a scatter plot. That's what a scatter plot is. And on your horizontal axis, it just puts your values for your observations, like you would have for your horizontal axis for a histogram, just something where you could put the data on. The vertical axis is this, z-scores of the percentiles. All right, I've seen people do these conversions in a like a spreadsheet format. We're not doing that either, right? All we're going to do is use our calculator to construct one. So we just need two things. What do we expect it to look like? And based upon the details of what it looks like, can we say that our sample fits a normal model? All right, so this is an example of a good normal fit. All right, even though this is slanted, see the slant? It is still lining up pretty straight. Like if I were to superimpose a straight line behind this, it would line up pretty well. Yes, you get some bendies here and here. That's kind of normal for the outermost parts. And you can see some trends here, a little bendy here, a little bendy here. But overall, it's pretty straight. You can't expect perfection from data. It's going to have variation, and you're going to see that show up. But if I got a normal probability plot from this, I would say it's gold. An example of a poor normal fit. All right, do you see this thing start to look like a chair? I mean, that's a big bend. that's a big bend. When you start seeing behavior like that, that is not a good normal fit. Okay, the more the bends, the more extreme the bends, the worse the normal fit. Now, I can't tell you where you draw the line between it's okay on one side and on the other it's not. It's a judgment thing. Maybe I would say, it's okay, I'll go with it. And you might say, nah, I'm not comfortable with this. So we can both be right. We just have to be able to defend what we're doing. Okay, so you've got a choice. If you're assessing normality, a normal probability plot would be a better option than a box plot because box plots don't show shape. And a mound-shaped distribution is a shape. I can show you a bell-shaped curve distribution, a uniform distribution, and maybe even a bimodal distribution where it's symmetric, and they will give you the exact same box plot. So you can't tell if something's normal from a box plot. It will show you skew, but not shape. Now, having, defended the normal probability plot and pretty much thrown out a box plot, you're not going to like this next bulleted point. College Board, we discovered, if we have to verify normality of our sample, then they accept a box plot, a symmetric box plot, as evidence for approximately normal. I don't agree, but I don't score those things and award you college credit. So what I would like for you to do for me is to make a normal probability plot and do it for College Board too, because they will appreciate it. It shows some sophistication beyond, just slapping together a box plot. But if you forget and just use a box plot, you're gold, I guess. All right? Now, your homework is this worksheet on assessing normality. It's just 3 problems. So if you have time to start your review number 2, that would be epic. That's on the assignment for tomorrow. We are not going to test on Monday. Tomorrow on Friday is a review day, but Monday is an even number day. So we'll test Tuesday. We're going to actually start scatter plots on Monday. So whatever I assign for Monday will not be due until Thursday because we have our test on Tuesday and we have kind of a spiral 10-question multiple choice quiz on Wednesday, right? Just to kind of get some kind of idea of where things are. So get ready for that. I know you're real busy. I know you have a lot going on with these 6 weeks ending, but that'll help you to factor things in. So we'll get out of here. This is all we talked about in this PowerPoint. So then, whoops, we don't need that. So then we went ahead and we looked through this, all right? We have 3 activities. We're going to do activity 1, activity 3 next, and we're going to do activity 2. In several of the classes, we didn't even draw anything here, but I am not going to take the time to draw things. I'm just going to refer back to things I already did draw, and so we'll just go ahead. So I need you to put these 18 values into your calculator. And so if you have an Nspire, it's going to look like this, all right? So label this X. Here's the 18 values. I have Y and Z here for the other 2, so we'll get to those. But anyway, put those in and perhaps pause. All right, so I'm going to assume you have these in. And the first thing we have to do is make a normal probability plot. So we're going to go home and we're going to open up a stats graph, which for what you're seeing here is this pink tile. And make sure you have given it a name, X or something, because if you don't, you won't see this little cloud of data points. Come down here and add your variable, and it gets that kind of weird little dot plot. We need to go and change the graph. So go back to menu, and we want plot type, and looky, normal probability plot. Okay, there it is. It lines up pretty well. This is a little off, this is a little off. Remember, at the end you start seeing a little bit of misbehavior, but in general I don't see enough bendies here for it to really matter. I would say this fits a normal model pretty well. This is just the equation of this kind of regression line. You don't need that. In fact, when we draw this, we're not drawing it with a regression line. So look, when you draw this thing, to show the evidence of normality, you just need this vertical axis and then this horizontal line halfway through. You don't even need any numbers. So let me show you what I did on mine. All right, I took a ruler and drew this kind of sideways T, and see, I put a title on here, normal probability plot. Don't do NPP. If you showed it to your parents, they wouldn't know what that is. If you wrote normal probability plot, at least they could Google it, right? And so just put in as close to what it looks like as you can make it, okay? Because all this is going to do is answer a yes/no question. All right, so that's it. And it's real quick and easy. That's all I need. Now back to the box plot, because it does ask you to do a box plot. We can change this graph to a box plot. All right, so menu, plot type, box plot, neat animation. See how symmetric that is? Now it does not show normality, but at least it shows the symmetry. Yeah, it's a little pulled this way, but for sample data, that's pretty good. Now, the other thing I want to show you, since I went ahead and built this thing, I want to show you how easy it is to build now that you can do this on your calculator. If you just move this cursor using your little touchpad here, see, that's your minimum, pops up 103. That's your Q1, median, Q3, and maximum, okay? And so I wrote this out as a 5-number summary, which I conveniently don't have on here. But if you look at the numbers, between here and here is about 20 units. And from here to here is about 20 more. And from here to here is about 20. And this is about 35. So all you've got to do is draw out, your horizontal axis and equally space the first 4 and then move the 200 a little further away. Draw 5 lines, box in the middle 3, connect the whiskers, done. You can do that in 30 seconds. And the symmetry here helps to support your claim of normality. This, of course, is the better argument. Okay? So, that's activity 1. We're going to scoot down to activity 3 and go ahead and, by the way, this is page 17 in your packet. The homework's on page 18. You can go ahead and put this in, and I think I'm going to pause my video while I put it in. I meant to have it in earlier. Somehow that slipped my notice. So give me a second, and I'm going to pause this. All right, so here I am back, and what I ended up doing was I went here. This is the last thing we were looking at. And you can just do Control, and you want to get back to this 1.1 page. Control and then left, and you'll move back in here. And I do have my data put in. I did label it Y, and there should be 20 values. So it's 2 more than the one we had before. And I'm just going to go ahead, now that I've got a data page and a graph page, I'm going to go ahead and do Control and arrow right, and I'm just going to change the features here to get the second normal probability plot. So I'm going to change this variable from X to Y. Oh, look at that. Look at the skew. That's right away completely not normal, because if something's skewed, it doesn't matter what the shape is, it's not normal. But I'm going to do a normal probability plot on this anyway. So menu, plot type, normal probability plot. All right, see the chair shape that this is making right here? It's pretty pronounced, right? Now this from here down is doing pretty well, like you might expect. But this side is pretty messed up. I think that's what we're seeing with the skew. So this does not fit a normal model. And we saw the box plot, it was skewed, so we have evidence of both. So this is what I have. This is my best rendition of what that graph looks like. And look, if you leave a few points off or add a few points too many, nobody cares. This is not meant to be perfect. It's just meant to convey what the outcome is, what the verdict is. All right. So this plot does not form a straight line. Thus, a normal model would not be a good fit for this data set. And we found from the box plot that this data set is skewed left. All right. All right, now remember, anywhere along the way, since I'm going a little bit more quickly today, you can pause, copy this down, do whatever you want to do. So if you need to pause, do it. So the last thing we're going to do is activity 2, and this is more or less calculator training. I think you already know the normal probability plot well at this point, so we don't need to belabor that. But we're going to do a simulation, and this is going to be something we'll do more and more frequently as we get further along. So in a couple of weeks we'll be doing this. All right, we're supposed to simulate 50 administrations of an IQ test. Well, look, that's normally distributed with a mean of 100 and a standard deviation of 15 rather. Now, no, I am not going to type in 50 numbers, especially since I don't know how those numbers might fit on a normal curve, because that's how you do simulation. If this is normally distributed, then the numbers I picked have to fit a normal model. We're going to use this, random, normal, 100, 15, and 50. So let me show you where that is in your calculator, okay? So this is where we left off. I need to be here. So Control, left arrow. All right. So go ahead over to your column that we put Z into, and if you haven't, put the Z there. Okay, once it's there, we need to go down and put in a formula, because your calculator can generate a bunch of random numbers and in several different criteria. So the formula, this is the formula panel, put an equal there, Z equals. All right, random normal is what we want. That's under menu and data. See the random popped up? Now I have a choice between random number, which could be any number, fraction, whole number, whatever. Integer is no fractions or decimals. Binomial, that's something we'll learn later. And that's normal. That's what we want. Random normal, because that'll help simulate that situation. So pick that. Okay. It takes 3 criteria. It needs to know what the mu is. That was 100. Now your comma is down here, lower left, below the pi key. So click it. And then 15, it wants to know sigma, and another comma. Then it wants to know, great, I can work with this. How many do you want? I think you can do anywhere from 1 to 500. The problem just calls for 50. All right, so hit enter. And see how weird these numbers look? They should fit a normal distribution pretty well. So this is kind of like a no-brainer. You pick normal numbers and then you check for normality. It better be normal. All right. So we're going to go back to the graph here. Control, right arrow, and we're just going to go ahead and change the this variable down here. Remember, we started with X, then we went to Y. Now we're going to just put Z in there. See how sweet that lines up? It does get a little bendy at this end. It gets a little bendy at that end. Normal variation for data sets, especially ones this big. Yeah, if you were to go ahead and build this by hand, which the last few classes I gave up and told them they didn't have to do it, there's actually points behind other points. So you're just going to make it look like this, even if it's only 35 or 40 or 45 data values. Just want a little curly Q here, a little curly Q there, and a bunch of neat lined up things pretty much in between them. Okay? So if you're inclined to complete this page, right, there is what it looked like when I did it before. It's a little different now because the numbers were different since they're random. And since it lines up so nice and straight for most of it, a normal distribution is a good model for IQ scores. Well, it better be, because we put the random normal into the normal. So if it's something else, then you really drew a bad sample. And really, in an earlier class, mine was kind of bendy. It was. We accepted it, but it was surprisingly bendier than what we just saw. Okay? So that's it. That's all I have for you. Yeah, you get a chance to do some calculator practice, learn a new graph, ramp up your sophistication with how you interpret distributions of numbers, that data sets and whatnot. So I am just going to upload this thing and call it a night. So thanks for watching.